Fins are typically produced through continuous stamping using high-speed punch modes. Fins can be categorized into the following types. 1. Bare fin, which has no coating. 2. Hydrophilic coating, usually appearing in blue or gold color. 3. Epoxy coating, often black or gold, providing the strongest corrosion resistance, but at a higher cost. If the operating environment is not highly corrosive, hydrophilic coating offers better cost-effectiveness.
Fin thickness can be customized according to requirements. The fin shape is determined by the fin stamping die.
Due to the high investment cost of molds, existing mature designs are generally adopted. Customized modes can be considered for large production volumes. Fin material, aluminum. Tubes are generally made of copper or stainless steel, with a small number of customers opting for aluminum tubes. Copper tubes materials are divided into 1. Pure copper. 2. Copper alloys, typically brass or cupronickel, selected based on the customer's operating environment. The inner wall of copper tubes can be 1. Smooth wall. 2. Microgrooved, as the microgrooves can improve heat exchange efficiency. Copper tubes exhibit excellent thermal conductivity and are simple and reliable to weld. However, copper tubes are costly, and the price of copper raw materials fluctuates significantly. To save costs, many customers choose stainless steel tubes. Stainless steel tubes are generally welded tubes, and the tube wall is usually thicker than that of copper tubes. Their heat transfer efficiency is lower than that of copper tubes, but the cost is significantly reduced. Tube insertion has hardly any highly efficient automation equipment and is generally performed manually. For short tubes, they are first bent into a U shape, and then both tube ends are inserted together. For long tubes, single tubes are inserted directly, and tube ends are connected using U-bends. The working principle of a heat exchanger is to transfer heat from the medium inside tubes to the tube wall, then to the fence, and finally dissipate it into the atmosphere. Tube expansion must ensure a firm bond between the tubes and the fins to guarantee effective heat transfer from the tube wall to the fins. Therefore, tube expansion is a core process in heat exchanger manufacturing, crucial for ensuring tight contact between the tubes and fins to achieve optimal heat transfer performance. Please note that the quality of tube expansion is difficult to inspect through appearance and leak tests alone. It requires the supplier to possess reliable tube expansion equipment and well-established processes to ensure consistent quality.
Tube expansion methods include 1. Mechanical expansion, known for its higher efficiency. 2. Hydroexpansion, generally suitable for tube bundles over 5 meters in length. Although slower and less efficient, it provides more uniform expansion. The welding process for copper tube U-bends is relatively mature. Typically, a welding ring or welding wire is used at the joint between the tube end and the U-bend, melted at high temperature to achieve a secure weld. The material selection and quality control of the welding ring are particularly important. Brazing materials mainly include 1. Phosphor copper. 2. Silver-based brazing material. The selection and proper storage of brazing materials significantly impact welding quality, particularly for silver-based materials, due to the high cost of silver. Some manufacturers use low-quality silver-based brazing materials to reduce costs, which can lead to numerous quality issues. Welding stainless steel tube U-bends presents certain challenges. Generally, 2 methods are used. 1. Manual argon arc welding. 2. Automatic welding, which can be divided into 2 types, with wire and without wire. Wire-free welding melts the base material itself to form a connection. If the heat exchanger operates under high internal pressure, automatic welding with wire is preferred. Leak testing is an essential step. Correct test pressure and sufficient duration are crucial for detecting leaks. it is unreasonable for many manufacturers to skip the leak testing step to save time. Drying is also very important to ensure that no oil or water remains inside the tubes.